Good afternoon, everybody. That wasn't the slide I was expecting to see. There we go, we're back to where we were. Good afternoon, everybody. Thank you very much for coming to our session. Today we're going to be talking to you about simplifying VCF deployments and operations using Terraform. And apparently the buttons have stopped working. I'm just going to put that down and you can press the button for me. I'll start with an introduction of myself. My name is Stefan McTighe. I'm a technical adoption manager at Broadcom. I've been working in IT for about 15, 16 years now, all sorts of different areas, and I quite like collecting certification badges, with the latest one this morning, actually. So.
Hi, James Tiffany. I'm a technical adoption manager as well. I've been with VMware for about 4 years now. And we won't talk about how long I've been doing IT for, because it makes me feel old. So
we've got the disclaimer. Please take a quick look. You've probably seen these in any of the sessions you've been to. So just quickly take a moment to take that on board. So let's get started. What is Terraform? I'm guessing the fact you've come to this session, people have at least heard of Terraform. Can I just get a show of hands? Who's heard of it? That makes life a lot easier. Excellent. Who's using it?
Wow.
Oh, brilliant. Excellent. You guys can come and do it then. Right, let's have a quick get into that for those of you who aren't sure what this is. So, infrastructure code. Any heard of that? Yeah, brilliant. So, Terraform is an infrastructure as code application. Plainly put, it is defining infrastructure or configuration through code rather than doing any UI deployment. One of the main things that's different about this compared to something like, let's say, PowerShell or PowerCLI that you may all know and love, is that it's declarative. You specify what your configuration is going to be. Rather than with something like PowerShell, you are imperatively telling it to do something rather than telling it what you want it to be. And that's one of the main differences.
So how can Terraform help? Well, Terraform is multi-platform. It allows you to take a common tool and run it against lots of different platforms. The great thing about that is you get to use existing skills, so people don't necessarily need to know vSphere inside and out to be able to take their existing Terraform skills and be able to start consuming them.
One of the other benefits is speed and efficiency. Anybody that's gone and deployed an element of vSphere, VCF, or just anything really in IT, if you're doing it manually by using a UI, it does take a fair amount of time. So why a lot of us today will use something like PowerShell or Terraform to actually be able to deploy something. The efficiency side of this comes from the fact that, James just pointed out multi-platform and being able to reuse it. You may have multiple instances of VCF or vSphere or any other product. You can actually then reuse this against different environments. So let's say you've got production, development, some sort of staging environments. You could reuse the same configuration with a different set of variable inputs and rinse and repeat that configuration somewhere else, hence getting you a lot more speed.
So reusability, as Stefan mentioned, you can take a bit of code and use it in production, test, dev. That same code will work in different environments, and all you need to look at doing is changing the variables, which we'll cover in a minute. But that means you can port that code around, you can use it multiples of times with only having to change a small amount of it.
And then finally, version control. This is quite an important one for myself. For years now, application teams have been version controlling their code, right? How many times in the infrastructure space do we get changes made by somebody? Sometimes it can be quite hard to track those back down through change control processes and records. What you can then start to do here is you've got a configuration file. You can start to version control that into some sort of thing like GitHub, others exist, and you can start to then map that against application code. So application code X can work with infrastructure code Y, and you start to get that control over there. And it can also be quite good from a recovery perspective as well. If you have, say, a ransomware attack on your infrastructure, you've already got all of your configuration in code ready to roll again. Should you need to in a different site or over the top of what you already had, it's there for you. So we'll just take a look at a couple of files. Again, there's quite a number of you here who've used this. So We've got two different file types that are used. We've got .tf files, which is the main bulk of your configuration, and we also have .tfrs. Within those files, we have various different things. So I'm going to talk about .tf files to start with. You can have multiple TF files. Terraform will look at a directory of configuration files and bring it all together and deploy everything that it sees in there. Benefits of doing that are that you can actually start to break out configurations into different logical entities with different files. Let's say you've got some compute configuration in one file, you might have some network configuration in another, you might have something specific for an application in another file. You've got different ways that you can break that down. And we do that by using various different data blocks or Terraform code blocks within that configuration. So we've got providers, which we'll go into more detail as we go through. We have resource blocks, we have data blocks, module blocks, and there is also the concept of an import block. Finally, touching back to TFRs, that is a slightly different configuration file, not only just in its name, but that is where you will store user-defined variables that you want to pass in with specific values into your configuration. And then just finally, if you, at any point we mention the word or the term HCL, it stands for HashiCorp Configuration Language, which is the language in which Terraform uses.
So then we get into TF state. So TF state is a file that won't be there at the start. That only gets created once you've actually deployed some code. And that is all of the configuration mapped to a resource. So it will be the information for like your edge or your servers or something like that. And the HCL lock, so the HCL lock is there. Stefan mentions that you can have multiple peoples working on the code at the same time. The HCL lock is there to stop two people making changes at the same time to the same bit of code.
Let's talk about variables. Everybody's probably clear on the concept of a variable. If anyone's using them in PowerShell, any other language, variables have existed. Terraform's no different. We just have a few different types. So quickly, we've got on the right-hand side, we've got locals. These are used for something locally within a configuration. You're not necessarily passing it through. It could be a value that you've generated through other parts of your configuration and then want to consume in multiple other places. A local variable can be quite good for that. You don't really want to overuse these. They've got a time and a place, and it is usually around repeating data that you want to reference multiple times. A user-defined, which would be something in your .tfrs file. These are probably the more common ones, and it's the most common way of passing in data into your configuration. So you might have a value for, let's say, a host name. You will have a variable stamped within your configuration. You would pass an actual real host name into that variable and away it goes. And then finally, we've got environment variables. So at the moment, we've just talked about host names there. Passwords are going to be needed as part of a bring up or most things you're going to be doing. You don't really want to be storing them just in a config file that you've put on GitHub because somebody's going to probably have a go at you and you've probably just leaked all your passwords somewhere. So by consuming them as part of an environment variable, if you were using, let's say, PowerShell as a terminal for deploying or executing Terraform code, what you can actually do is start to pull in those password variables from an outside source, let's say a password management solution, into an environment variable using this prefix, and it creates an environment variable within the terminal. This is a PowerShell example, and it uses tf_var_ variable name as kind of a prefix, so Terraform knows that those variables are for Terraform.
So on screen there's a couple of examples of variables. If we look at the bottom one first, the variable, you give it a name so that it can be referenced in the code itself. So that will be what you see throughout the actual code. You give it a type, that can be string, boolean, number, whatever you need to put in to define that. Now, we mentioned around this is shareable, so in the description, the more information you, or the better description you can give it, means that someone else can pick it up and run with it at a later date if need be. A default will mean that it will use that setting unless you tell it otherwise. So for a lot of the stuff we've been doing in our code, the administrator at vSphere.local is the one that you would use. So we've added it there. And sensitive equals true. So Stefan mentioned around being able to pass passwords in and things like that. Once that's in the code, you don't really want it being displayed on screens or in log files. So if you set the sensitive equals true, then it won't pass that out into any logs or anything like that. So you don't have to worry about that being shared with anyone. And the one at the top is sort of like the next level of it. So once you've started configuring it, you can actually start setting validations on it. So on the example there, we're saying that the input into it has to be in a CIDR format, and if it isn't, then it'll error. So you can start adding extra bits of configuration in to enable you to make sure that the information that's passed into the code is what you're expecting at the other end.
James talked about a state file earlier. I just want to go into a little bit more detail because they are quite important. Where we've got that mapping to a real-world object into your code, you need to store that state information so that if you were to create another object with the same name, it isn't actually the same thing. So therefore, if you're changing configurations, you don't want things to break that you didn't intend to break. So these state files need to be kept. So you've got, by default, local state, where it will just keep it in the directory in which you're executing your code. But that's a little bit painful when it comes to trying to work as a team, because you've got the code locally on your directory. That hasn't been pushed anywhere. Nobody else can see that. So you can have the concept of a remote state. So you can configure Terraform to say, actually, please can you go and put this somewhere else in a centralized location that can be consumed by lots of different people and be more collaboratively worked upon. It's also more secure. So if you are going to start using something like this, remote state is ideally what you want to be using.
So modules, they allow you to interact with, so Terraform is the construct, and then you use a module to actually be able to interact with objects that you're looking to do.
One of the key extra benefits with this is, again, coming back to that reusability piece. If you're, say, deploying lots of clusters all the time, because you have a work stream that is what it involves, you don't want to necessarily keep writing out the same piece of code around deploying a cluster every single time you need to do a configuration. What you can do is have a module which is effectively, let's call it like a templated version of that code, which then you can keep as an independent piece of code and then reference it from lots of other different configurations. Again, builds into that reusability piece. And I'm only going to briefly touch upon this because there's a whole world of other things to go into this. We don't have time for that today. But you do have the concept of importing existing configuration that is outside of Terraform's control into your Terraform configuration. Now, when we say import, it doesn't go and look at a piece of infrastructure and then write the code for you. You still have to write the code. But what you can do is then pull existing objects into the state. When it comes back to those state files, it will say, hey, I've got some configuration that looks like that. I want to map them together in that state file. Terraform now can continue to manage them, change them, etc.
So what you're seeing up there is just a basic workflow. So an engineer gets given a task, they need to write some code for it. They'll write that code into configuration files. That will use a provider to interact with the objects it needs to, and then at the end of it you'll have infrastructure that's been deployed by code.
And there are 4 main commands that you'll probably use. There are more than 4, but these are the 4 to kind of get you started. So to start with, we have Terraform init, which is how you can actually initialize the code in the working directory that you're executing Terraform from. We then have Terraform plan, which is effectively a what-if statement on PowerShell. Is, I would like you to tell me what is going to happen when I run this piece of code, what's it going to give me? And you will see in the demos shortly, it will actually list out all the infrastructure it plans on adding, changing, or potentially deleting when we get to this one in a second. So you always want to be running a Terraform plan, and you can actually output a Terraform plan as a file to consume in the next one. which is the apply. So Terraform apply is you actually applying and executing your code to the piece of infrastructure. In this particular instance here, we're specifying our separate variables file. You could have various different variable files for different environments, and depending on which environment you're running the Terraform configuration to, you might have your production set of variable data, it might be your dev, it might be test, helps with the consistency of the environment, etc. And the interlink between those two is that if you output a Terraform plan to a file, you can actually pass that back in when you do Terraform apply. So you've planned your state, you know exactly what you're going to be getting. Please now go off and do it when you hit Terraform apply. And then finally, Terraform destroy. It's really easy to press that, and you can just watch everything you built go away. So do be careful when you're running a Terraform destroy. Anything that is defined in that configuration in the directory that you're running in, if you type that, and you didn't mean to, you probably want to go home for the day, because you're probably not going to have a very good afternoon. As powerful as Terraform can be, you are declaring a state. That could be a state of nothing at the end of the day. So always take a minute before you want to run anything like that. But it's really helpful for lifecycle, right? We constantly are deploying infrastructure for projects and things like that. How many times do people end up that they come along to a piece of infrastructure 5 years later and go, why is that still there? Nobody actually got rid of it. You can actually complete the lifecycle. You deployed it, or you wrote it, you deployed it, you used it, you got rid of it. Helps complete the whole package. That is a QR code to the VCF Terraform provider. So if anybody wants to grab a picture of that, that will take you through to the GitHub page, where you'll be able to see all the information, and there's various links away from that that you can take you to all the documentation, etc. So let's get into some and if I can take over the driving, James, as I flick between different screens. So I'm going to give you a quick demo first and just talk through a few things, and then we'll have a quick look at the code. So this is a VCF bring up. Anyone that's done a VCF bring up before, you potentially have used the Excel parameter spreadsheet or a JSON file. We're probably doing something kind of similar, I guess, in that we're still going to articulate all those values, but this time we're actually going to put them into some Terraform code. So on that particular screen, you don't actually see the values that we're passing in. You're seeing the variable placeholders for said values. We've also then got the variable declarations that James went through earlier, where we're talking through those types of strings. But what I have been doing down the bottom that you'd have seen going through was I've initialized a directory. So I've gone into a directory where my code is. I've done a Terraform init. I've then done a Terraform plan, and you would have seen that it then put out a big list of here's all the objects I'm going to create. And what it said was that it was going to add one thing, which was a VCF instance. And we've kicked it off. So now it's going to start going through. And then for comparison, it kind of then shows you what's really happening. So anyone who is familiar with the Cloud Builder, Terraform has now just gone and interfaced with it through the Terraform provider for VCF. And is effectively just executing against Cloud Builder. But you don't have to go and do it. It's just to give you the kind of the visual of it's taking all that away from you, from having to go through that UI yourself, do it in code, delivered, and you'll see we've got an end result. And then I think you can see in there it was around 2 hours 45, and that was in an environment that wasn't necessarily powered very well. So it's quite a small lab. So you can imagine if you were doing that on something that had a bit more oomph in the hardware, it can happen even quicker than that. So let's just have a quick look at the code. So we mentioned different resource types or data blocks within here. So we are defining here a resource of a VCF instance. We are passing it all manner of information. We've got information here around the SDDC manager, credentials, NTP, networking for vSAN, vMotion networks, etc. We've got in here, I think, some NSX configuration, IP pools, network I/O control, cluster information, there's vCenter, you name it, whatever you need to bring up a VCF configuration, it's in that file. And hopefully what you can see over here on the right hand side is this is the directory that we're working in. We have a main file, which is the bulk of the configuration. What I've actually done is then separated out the provider file. So this is the connection details for how Terraform will configure, interface with the endpoint. In this case, it is Cloud Builder. There are different versions you can deal with. So this is a slightly older version now. We're actually on version 0.11.0 for Terraform provider. 0.12.0 is due out quite soon with some additional features that have been added in, which is great. And again, we've had a little look at this file already, declaring variables. Various different ways you can do these. I'm not going to go through them in too much detail because we could probably spend the entire remaining 25 minutes on that. So we'll skip over that a little bit. But to give you an idea of the TFRs file, it's just key value pairs. And there's different ways you can nest these, different practice on how you can use it. Depends on the use case. As we go through the demos, you'll see different uses of them in different places. This is defining a single value for each variable, and they're all singular. So kind of giving you in a very basic form. It will get a little bit more funky as we go along. So that was the bring up. So I'm going to switch over to James, and we're going to talk about the next.
So once bring up's complete, there's still a number of actions that you need to take to make the environment usable. So next on the list is the NSX deployment. So again, in the demo, you should be able to see.
Yep.
As we did in the last one, the initialize. We should speed these up a little bit, but so it's going through all of the steps that you need to do to be able to do the deployment. We're calling the specific variables, and you should see in a second. Do you want to click it on? Or?
It'll get there just a second.
And again, so you'll see as it starts going. So it will go through, and it will tell you as it's going through. So you can then use that to wait for potentially the next steps if you were chaining things together. And you can see in the SDDC manager, the tasks are kicking off. You can follow it in there if you want to. But the whole point of this is about code. This is just as a demo. And then you'll see it go all the way through to the end. Then we show the next bit.
Cool, let me click on that code. Sorry, James. There we go.
So as before, we've got the main TF that's running. It's got all the config in. So this is where we're calling all of we're telling it what variables to be using. So in here, you're looking at all the information that NSX requires with IP addresses, uplinks, BGP if you're using it, OSPF if you're doing another one.
The other files are exactly the same, so I won't show you those.
Oh, no, go to provider.
Oh, sure, yep.
So in the one Stefan showed you in the provider section, he was calling Cloud Builder, because that's how you do the bring up. From now on, we're targeting the SDDC manager, because Cloud Builder's gone. Once you've done the bring up, it's not needed anymore. So in the provider file, we now reference SDDC manager rather than Cloud Builder.
Okay. So let's have a look at our next example. So now we're beginning to shape up. We've got an SDDC instance. We've got some edge node NSX boxes. Let's start looking at some of the other steps now. You know, we've got the base of our infrastructure, certificate management. So anybody who is running an environment these days of any kind, certificates are a big part of that, part of the security models. So let's have a quick look at what that looks like here. And what you'll begin to start to see is a bit of a pattern in terms of this code all starts to look the same. And yes, there's quite a few lines of it. But once you've got this basis, the rinse and repeat kind of element of this is that you can take those blocks of code and keep reusing them. If you're going to build another environment, you're going to build a whole other separate system somewhere else, you can take that same code and keep using it once you've done it that first time. So again, what we've got in here is various different resource blocks. So we've been building a certificate authority. Sorry, we're not building a certificate authority. We are configuring a Microsoft certificate authority that already exists into SDDC Manager. We're generating the CSRs that are required, as you can see there on the right. That's now skipped to generating certificates, actually. We generated the CSRs. We then pass those CSRs into the CA. certificates came back to SDDC Manager, and it's now deploying them. We talked a lot about kind of speed earlier, and Terraform can do a lot of things in parallel if there is no dependency between the two. This is probably one of the exceptions. So unfortunately, you can only do one certificate operation at a time, so this will actually do it in series. So you don't necessarily get every speed benefit, but it will just run the whole thing back to back, no waiting in between. But if you have got like more than 3, 4, 5 certificates, depending on how big you've built this out, you're going to have a little bit more time that's going to take on that. It won't go and deploy, let's say, your vSAN certificate and your NSX certificate at the same time. It just won't do it. We'll have a quick look at the code for this one, although you can see most of it on screen. All very similar again. We've got a main file. We are declaring, if I scroll up, there we go, the certificate authority, and we're passing in different things, the template, secret values to get into the CA, etc. The different CSR values for the first few, and then we've got NSX. There is one extra little bit in here. So sometimes you might have a piece of data that you need to consume which isn't currently available in the VCF Terraform provider, or any other Terraform provider for that matter. There is a really cool module out there called TerraCurl. If has anybody heard of TerraCurl actually? I'm intrigued. Oh, best thing ever, isn't it? So it's basically a Swiss Army knife. And what we've got going on here is we happen to, at the time of starting to try and write this, we required a domain ID, which we couldn't get natively. So what we've actually done is using TerraCurl, we have used the API directly in Terraform and outputted that as a local variable to then consume. So if you do have gaps that you need to be able to do something, you will be able to fill it with this. It is the Swiss Army knife of taking things that aren't Terraform controlled and making them Terraform controlled. So you actually now don't need to use this to get the domain ID, but at the time of writing, we did. So that feature's already been added into the provider and is available now to consume natively. So right, let's go back over to here, and we'll move on to our next demo.
So now you've done the certificate replacement, a workload domain is what a lot of people will move on to next. So do many people know what workload domain is in the VCF construct? For those that don't, a workload domain is a separate bunch of resources that gets its own virtual center, its own NSX, and can be controlled that way. So what we're doing here is, this is actually a combination of quite a few tasks. So whereas the other ones might have only been one task, in here, this one is actually doing multiple things. So the first thing it's doing is commissioning the host. So that's taking the information of the ESXi servers that are going to be used for that workload domain. So they're the compute resource. And it's adding it into the SDDC Manager database so it knows about them and then can use them later on. So once it's done that, it will go through and it will move on. So it does a check to make sure everything's good, and then it will start actually deploying the environment. And as you can see, by the end of it, you've actually got a new set of NSX managers, you've got new virtual center, and in this example, they're linked SSO, so you can see them from the same construct. But that's taken multiple jobs. It's not just deploy a workload domain. You had to chain a number of tasks together to get that far.
So let's just take a little look at that code and what that might look like.
So the bit of code in blue is we left it in an example. So when you're creating a new workload domain, you can use an existing network pool, or you can create a new one. So you have the ability to create that as part of your job, and at the end of it, you can pass that information into variables. So in our lab environment, we didn't have enough networks to be able to do that. So we were actually reusing, and that's where, again, TerraCurl comes in. And you can see the network pool ID is being called as a local. So that was piped in using the TerraCurl information to get that. So we needed that in there to be able to reuse what was already existing. If you're creating new, you can just pipe that straight into the code once it's complete. And again, that's got all of the host information that you need to add it into the SDDC manager. And this one's this one has a lot more information in it because it's pretty much similar to the bring up minus some SDDC stuff in that you have to give it the host information, the virtual center, the NSX, all of that information to be able to create that new environment.
Just one thing to add here as well, we left it in as an example because Terraform can be really helpful when you're in a jam, but the network pool ID is now actually available as a data source within the provider in the newer versions. Just at the time of writing this, we weren't able to have that because it wasn't actually done yet. So, we are getting now to our last demo. VCF credential rotation. Credentials for me is always something that seems to get left out when people are deploying infrastructure. How many people don't rotate their passwords today, or very frequently? Or are you all fantastic and no one wants to admit that they don't? Yeah, I don't believe you all. So within the SDDC manager, there is the ability to do password management. What we can actually start to do though is apply, again, desired state. I don't know what that is, but it sounds fun. Okay, awesome. Bit of background music for the last bit. What we're doing here is we're taking the NSX objects, that's very distracting, and we're actually going to do some configuration against them. So one of the key things here is actually setting those auto, can you all still hear me okay? Because I can't hear myself at all. Okay. We want to be able to set a couple of things. One, a rotation schedule, so that do we want to do it every 7 days, 30 days, 90 days, based on your security policies, or do we actually, well, in fact, that's the main thing as part of this one. I'm getting a little bit confused with our API talk track that we do as well. So in this particular demo, we are taking all of the NSX accounts, so audit, admin, and root, and saying every 7 days, I would like it to automatically rotate those passwords. They would then be available through the various different methods of extracting passwords. So for instance, password underscore lookup from the SDDC manager CLI, PowerShell, various get passwords. I'm having real trouble trying to concentrate with that going on in the background. Let's get on with the video and you'll see what we're doing. So again, we've got the rotation days that we've noted up here, and I'm in this particular case doing 7 days, and I want to enable that auto rotation. So off it goes, all the different accounts. One of the extra things that we did doing that, and I'll show you in the code in a minute, was rather than do a separate block of code for each account, we actually put that into a for each loop, in effect. So anyone that's comfortable with PowerShell has come across a for each loop where you can just start passing in multiple values and running it through the same code. You have the same concepts in Terraform as well. They can be really, really powerful. Can't use them everywhere, but in most cases it can be a really, really cool thing to take on. Rotation schedule up there on the there, and it tells you also when the next rotation is going to be. So if I can get my mouse to go back, let's have a final look at that bit of code. There is also, we didn't want to show you this because it's a little bit repetitive from workload domain, but you can also just do individual clusters. So if you wanted to deploy additional clusters into a workload domain, there's code that you can do all that with. Looks very similar, hence we're not going to bore you with it right now. So that's what the main file looks like. You can see here that I am passing the data objects that I have acquired here, and this is one of the first times you're seeing a data object rather than a resource object. So a data block is going to get existing data about something that already exists. So that, in this case, is a set of credentials because they already exist in the SDDC manager database. I don't want to create a new one because that would just break things. I want it to go and get it and tell me about it. And then what we're doing is making use of an array of local variables, and we've nested 3 different lines within that array, and we are passing that through to set this. So what we can then see here is we've said for each. So every user that is in my local users variable, I want you to run through and apply that policy. And here we've got the resource ID, attribute, and also the type, which in this case would be NSX, and we've got the username. And there we go. We've got that all done. So that is the end of our demos, but we're going to talk a little bit about going further.
Yeah. Change.
Oh, thank you. Here we go. So there's lots of things you can then do with this to kind of bolt it into wider solutions. So CMDBs and ITSMs, we've talked there about environment variables and defining things, pulling them in using local variables. You could be getting them from somewhere else. That could be a dynamic data source, like an ITSM or a CMDB. So you may have already entered the details for an ESXi host, for instance, into a CMDB as part of another commissioning paperwork process. You can then go and grab that data, pull that into your configuration for environment variables, and start to chain this together into bigger workflows using things like VRA, other different continuous integration tooling, and away you go. So I've mentioned automation there again. You end up here, you can start to have catalog items now. I want a test VCF environment for a project, for instance. Somebody can go into a self-service portal and go, I would like one, please. Away it goes. That could be as integration-wise as well, things like IP and DNS management. All starts to get very dynamic then and doesn't have to be defined specifically in a configuration file. And then finally, you've got to use the right tool for the right job. Terraform is infrastructure management. Configuration doesn't stop at just the infrastructure. You've now got to do your configuration management of it. There might be further things you might want to do. We've spoken a lot here about the VCF bring up. You're not really deploying applications as part of that, but you are going to at some point deploy applications after this. That is going to involve virtual machine deployment, most likely, container deployment. There is going to be configuration that needs to go on top of that. You can then start to bolt all of this together into automated workflows.
And so a really good resource to maybe help get you started. So although we've gone through being able to do everything from bring up all the way through, some people might want to start a different place. You might have an immediate use case that you want to solve. Something like Holodeck might help you start on that journey. So that is the ability to have a VCF, nested VCF environment. So you could use that to get started to then be able to start maybe writing your code on top of it. Once you're at the stage, you can then maybe drop down and start writing the Terraform code to actually do the bring up as well. But this is a potentially very quick way of getting you started on that coding journey.
And that is it from us. Please do the survey. It really helps us out getting the feedback so that we can develop further sessions or adjust these as we go. So it would be great if you could fill those out for us. And if you did want to continue to talk to us, we will be hanging around for a while, so if anyone wants to come and have a conversation with us, talk about any use cases or anything you've heard today, please do come and have a chat. You'll find me on Twitter or X or whatever it's called these days. James doesn't really live in that generation, so doesn't like it. But we have a shared website as well now, just happens to have my name. But you can find all the content that both of us produce, especially around these types of topics, is all available up there. And all the code repo that you looked at today, including the example that we didn't go through around clusters, is all available at that QR code at the top there. So there's all complete working examples in there. Although I say working, they were working when I put them there. Things have moved on in IT a few weeks since then, so who knows. And we're both on LinkedIn, should you want us. And we've got a few minutes for questions, but I just do want to do a bit of a plug. Myself and James were out in Las Vegas. We were lucky enough to be able to get out there to speak to people on the US side of the world. We did the hackathon. I don't know if anyone's ever done the hackathon before or heard of it. Anyone done it? No? This by far was one of the most interesting and rewarding things I've been involved in. So myself and James were part of a team who we happened to actually win the hackathon, which was kind of cool. And we did some really cool stuff with Terraform and VRA and bringing them together. Again, if you go to the QR code where the repo was, you'll also, if you go back a step, you'll find all the hackathon code. But there is a hackathon for EMEA, which is happening tomorrow, 6 o'clock. Really worthwhile. If anyone's just been umming and ahhing whether they think maybe a bit not my thing, or don't really feel perhaps I can bring anything to it because maybe you're not as command line driven or code driven as an individual, it honestly doesn't matter. In our team we have people who were like full-blown experts and could write anything in code, and we have some people who had never written any code before. Everybody had a good time, you learned a lot from it, so if anybody is thinking about going, and even if you weren't thinking about going, now go and think about going, go have a look at it. Honestly, you'll have a great time. And we've got 5 minutes left. Anybody got any questions? We're going to have to come over to you and I'll relay your question to the audience.
When you change the password, where is stored the password?
Okay, let me just repeat that, sorry. So the question here was, when we are doing a password rotation and it is changing it, where is that change ending up? So that will actually go into the SDDC Manager database. That is where it is stored securely, and then you can extract it using either the CLI password lookups. That's the right command, isn't it?
Yep.
Yep. PowerShell, so there is a Power VCF module as well where you can go and extract that, and you can pull that out into a database for you to consume. You can then put that into your password management solution somewhere else. Sorry, say that again.
The password is encrypted?
When you run the command to pull it out, it will be plain text in front of you. In the database, the password is encrypted in the database, isn't it?
Oh, yeah.
Yes. I didn't want to say yes for definite without confirming.
No,
Brilliant. Thank you for your question. Oh, I can't even... even better. Thank you.
Yes, it's working. The Terraform module, it follows very quickly after release of VCF.
I actually need to come and stand by you. I can't hear you over the noise. James, do you want to try and grab that question? Sorry, the background noise is quite...
Yep.
High up.
After the release of VCF, how long does it take to have the update of the Terraform provider?
So the question was, how long after a VCF release is the Terraform provider updated?
Okay, so that can depend. It depends on what's necessarily changed. So it is usually fairly quick. So at the moment, the latest supported VCF version officially that is available on provider 0.11.0 is VCF 5.1.1. 5.2 should work, but that isn't official. But the 5.12 release is imminent. So I would say it's somewhere between a few weeks, maybe a month. It's really hard to confirm. But what I can do is, if you want to grab us at the end, I can put you in touch with a gentleman over on the booths who will probably be able to give you a slightly better answer than I can. All right, thank you for the question. Any other questions? No, all good. Oh, look at that. We finished with 2 minutes to spare. That's unlike us. Thank you very much.
Thank you, everyone.